The combination is a mathematical technique or a tool that determines all the possible ways to group a certain data. In combination, the items can be selected in any order. The order of arrangement does not matter, unlike in permutation. So it has a lot of real-world uses. For instance, when we're, making up teams or different committees, or we are selecting subjects, or when we're making lottery numbers, because the arrangement of the lottery numbers does not matter. In other words, the 6 numbers that you've decided to pick in a lottery do not have to be picked in a certain way. They can be picked in any order. I've chosen here a cyclist team, and the team has to consist only of 4 people, and they need to be chosen from 7 males and 6 females. So altogether you will have 13 cyclists. Now, in how many different teams can be chosen if there is no restrictions? Or let's do another one. There must be 2 cyclists of each sex. Or in the third example, we are going to look at least 1 sex of each cyclist is required. So let's firstly calculate how many different ways can a team be chosen if there are no restrictions. As there are 7 male and 6 female cyclists, therefore there are 13 cyclists up for selection. And here is our formula for the combinations. But we can also write this as, and often it is just written in brackets, where n will denote the total number of cyclists. And this includes male and female, so we'll have 7 plus 6, that will be 13 cyclists. And R denotes the number of cyclists in the team, which we are given to be is 4. And so we use our formula and we will write 13, the total, 4 in the team, and now insert it into our formula here. It's 13 factorial 13 take away 4 factorial, and R here will be 4. When I expand this, I will have 13 times 12 times 11, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and we'll also need to do factorial 4, which is 4 times 3 times 2 times 1. We can cancel 9, 8, 7, 6, 5, 4, 3, 2, 1 and 9, 8, 7, 6, 5, 4, 3, 2, 1, and when we multiply the rest of it, we should have 715 ways to choose the team. Now you can see that doing manual multiplication can be quite horrendous if you've got a very big number. If you have the calculator, just find the combination symbol on it and use that. For this question, we want to find 2 cyclists of each sex. It may seem to you like, oh no, how difficult can that be? But it will not be so difficult at all, because we're going to look at each sex separately. If I write it out in a sentence, this is what I'm asking. In how many ways can I choose a male, and in how many ways can I choose a female? Remember, there must be 2 cyclists of each sex. So the number of males I have is 7. So therefore I have 7 males and I have to choose 2 of them. I also have 6 females, and I will also need to choose 2 of them. In other words, I can rewrite this and I can say the males can be chosen, and we're looking also at females. The females can be chosen. When you see this in written form, you notice that I specifically looked at the word end. The word end denotes multiplication in mathematics. And so we could write this as 7, 2 combination multiplied with combination for the females 6, 2, and work it out on the calculator if you can. That will give you 315 different ways. Otherwise, we'll use the formula above. In this last question, we want at least 1 sex of each cyclist required. At least mathematically means that there must be 1 or more. So we could have 1 male and 3 females, or we could have 2 males and 2 females, or we could have 3 males and 1 female. Writing it out like this allows you to see where the end words are and where the or words are. So whenever you've got an and word, you're going to use a multiplication. Wherever you've got the or word, you will use an addition. And multiplication, or will be addition. And will be multiplication. That's really very important. So I can highlight this and, or, and. We can write this in the combination formula. 7 males, 1 male only from 7. We will multiply this by, we need from 6 females, we can have 3 females, so 3. Now we will add, now we are going to choose 2 males out of 7, and we're multiplying it by 2 females out of 6 females. Now we're going to add 3 males out of 7. 7 males, we want 3 males, and we're going to multiply that by 6 females, but we only want to choose 1 female out of each. Now we can substitute these numbers into our combination formula that I've introduced to you above, or you could use the calculator. Select the options button and go to the probability menu, and you will find the combination formula there. And you should come up with those 3 results over here and just add them up. And the result should give you 665 ways. Now these combination numbers can be taken from a Pascal's triangle. I will put another video on straight away after this, and so to show you how to use the Pascal's triangle to add these combinations together. If you've watched this video to the end and you appreciate the video content, I would really appreciate if you could subscribe to this video and press the like button, as this allows the video to reach a wider audience.